I got nothing to do today, so I'm trying to learn how genetic algorithm works, or algorithms, and trying to make a program that guesses or that tries to reproduce an image um, by generating a random color in a 2D array of colors. And well, here it is so far. So I have a population size of 150, which is relatively small, but you have to realize that I have to make an insane amount of pixels every frame, and the mutation rate is about 5%, so I could make that a little bit lower, but the main problem is actually that well, there's a bazillion pixels that something can choose. So to pick randomly the first any pixel correctly would take too long in the first place. So what I'm thinking of doing is instead of choosing a random color, just random RGB value, is to create a set of colors that are found within that image, and only picking from that set. And then an improvement I can do later on is to also introduce random colors, say like double the size of the set. You know, half the set has the colors that are actually there, and the other half of the set has random colors, that completely random. So that's what I'm thinking of doing. Wish me luck. Alright, see ya. So I went ahead and added that improvement. So you can see here I have this set of colors, and at every color I add to the set, and I just copy the set to the array of colors. And then instead of choosing a completely random one, which I've saved to that algorithm here, I choose a random element from the color set list. And I also added the original image to the side of the random one, and you can see the random one has a lot more of similar colors to the original image. So hopefully this is an improvement. I might need to reduce the size of the source image for testing purposes, so choose a smaller image to test with. Alright, I'm gonna try that. Okay, so this is actually really exciting. I fed it a smaller image. This is only a 32 by 32 image, but as you can see, it's already starting to take shape, and I really should add some more information of what generation we're on. But as you can see, the best, I guess, child of every generation is getting really close to the original image. Of course, there's only three possible colors. There's the green, there's the blue, and there's the transparent. So I might go ahead and just turn the mutation rate down to a straight up 0, because this has a relatively large population size. I'm gonna try that and see how that helps. Alright. So just one thing, I actually didn't change the mutation rate. All I did was chose a smaller image, and you can already see that the image here is really starting to take shape. So if it ever makes it, I'm just gonna leave this running for probably like 10 minutes, see if it makes it, and if not, I'll tweak some of the bits in the algorithm again. This is a 16 by 16 image, so it's much faster to do generations much quicker, and it's again only 3 colors, so it's much easier to guess the colors correctly. But you can already see how close it is to the original image, which is a really good result, but it is very fabricated. So I need to obviously tweak the algorithm a bit more. All right. So I tweaked it again, and so basically I bumped up the population size, but I also turned the mutation rate down to 0. And you can actually see the problems with doing what I just did, because I got a really close image to the original one, but 1 pixel's off. And the reason for that is because it was never mutated into the correct color, which means in none of the generations that pixel did not turn green. even though I had such a large population size. So I'm going to try turning the mutation rate back up to 1% and see what happens. And there it is, with a mutation rate of 0.1% and the population size of 5,000. It has recreated the image. I wish I'd been filming it in the last couple seconds. This is actually pretty great. There are some improvements I'm going to make. Instead of using a set for the colors, I'm going to use a list. So what I learned is basically doing this kind of random, almost pseudo brute force genetic algorithm doesn't work with such big sets like an image and colors, because there's just a lot of data. So obviously better algorithms must be used, something like more on the deep learning side. I mean, this algorithm doesn't really learn, it just randomly picks a color and then chooses which one to keep based on fitness. So this is more of a classic algorithm, but you can see with the 16 by 16 it works pretty well. You can see it's kind of stuck there. I don't know why that is. Maybe it needs a bigger population size or something. I honestly don't know. But it got there, and it got there once. I was just trying to reproduce it. So, but that's about it for... I know I don't usually talk about this kind of stuff at all. But this was more for me, because I wanted to kind of document my thought process of building an algorithm like this, because I just think it's important. So I know this was probably kind of boring for most of you. Probably don't care, probably just skip through it. But for those of you who stayed, cool, I guess.